if you have downloaded the PDF, that's what the book looks like. You can also view it online. Let's see. Oh, either way, George. As long as I can, as long as you got enough work on there. Yes.
So my internet is really bad. I think we're gonna get it fixed soon, but it keeps putting me in and out of the Zoom, and like you're freezing and breaking up really bad, so I can't understand what's going on. And it keeps taking me in and
That
out.
would
So
make it
do you just want me to watch the recording? Do you just want me to watch the recording, or?
That is up to you.
Well, I don't want to like be absent or anything.
I understand, but you're communicating with me. That's the important thing. So it's not like you can't miss anything. It's just you can't disappear and not tell me what the hell's going on. And you're telling me right now.
Okay.
So, okay. Yeah.
All right. I'll try to stay as long as I can.
Okay. Are you good with the homework now, I guess? Or what's up? We figured it out?
I kind of understood what you said, but you kept breaking out. So I think I know where to find it.
So the chapter 1 homework is just at the end of chapter 1. It's the chapter 1 review exercises. Yeah, and if you view the book online, I think, right? Yeah, you can. There we go. You can just click right on review exercises, and it takes you straight to it. That's crazy. Crazy.
All right.
Yeah.
All right.
All right, guys. Anything else? What did I miss here? Somebody. All right, I got a couple of questions. I love it. 68 from chapter 1. Are we still typing anything in the chat for roll? No. No, you're not. You're just making sure that your name is your name on here on the Zooms. All right, wait a minute. I normally don't take roll at all. Yeah. Oh, sure.
So there was a survey that you had put on the modules. How do you know if you completed it or not? Because it doesn't say a check mark.
Because I can see your results.
Oh, I knew that.
So yeah, so that's all right. So let's talk about that real quick. You might have noticed, you might get a notification that I added a survey in. Let me become a student. Become a student. Rawr. So now there's a survey right here. Right, so if you work, hopefully you've worked your way through this already so you can do the survey. And it's not that many questions, just please take a couple minutes to fill that sucker out, right, the survey. Like you just said, there's no way for me to make you turn something in. It's on this thing called Statcrunch, which is kind of nifty because then I can analyze the data really easy. So let me show you what that looks like. Let me become not a student. So much extra stuff. Yeah, so here if I go to the survey, click on the survey. This will be a good check. Oh, good, I got the right one. What's your name? When the last time you took a math course? And there's only 12 questions. Come on. Easy peasy. I like it. Is that all right? You guys, so do that survey for me, please. Let me see. I got a question from chapter 1, number 68. Oh, where have I put the book? Oh yeah, it's over here. Bam. 68. So this one is, oh yeah, that's right. Okay. So let me do it up here on the board. Okay. I'll do one like it. Straighten my house up a little bit. Ooh. I'm sorry. What did it look like? So if I thought we did one like this. It's a little bit different, isn't it? Sure. Okay, I like it. All right. What would I do first here? Would I just multiply this guy by a squared minus 4 and multiply this guy by a squared plus 4a plus 4? Hell no, that would be insane. Don't do that shit. What do I do first?
Factor.
Factor, exactly. I want to see what the hell I'm working with, right? I'm just going to cut to the chase here. Now I see what I already have and what I'm missing. What's this first guy missing? What's he missing that he's got? Sorry?
A plus 2.
No, he's got a plus 2s, crazy amounts of a plus 2s. What's he missing? That
A minus 2.
A minus 2, I like it. Aw. Poor little dude. Aw, poor little dude. It's my calculator. All right, that'll be all right. So multiply by a minus 2. There you go. Now we're talking. And what's he missing that he's got?
A plus 2.
Yeah, he's got 2a plus 2, so he needs one more a plus 2. Is this cool? Is this, I mean, this is, so now I've got 7a squared minus 14a. Now be careful here. This is where people make an easy mistake. And the best way to handle this, make this plus and negative. Now you see that the -3 goes through. That is the most common mistake. And on the bottom, I just got all this shit. All right. Is that
You
cool?
multiplied the a minus 2 to the first term and then put a square on the a plus 2 on the bottom. Did you mean to do that, or did you mean to do it for the negative?
Wait a minute. What's happening? So this was here to begin with. This piece was here to begin with.
Oh, you're right. My bad.
Okay. That's right. I am right. This time I'm right. Okay. Please call me out though. You never know. I make mistakes. Oh shit. Wait a minute. Let me finish this up. And then of course you put your, is that cool? Is that all right? You put your like terms together and you see if you can factor it. I don't think this is factorable. Is it? No, it almost is. That's interesting. No, but it is. All right. I mean, so you do the same thing with number 68. Is that all right? 68 is not the same as this, but it is exactly the same as this. The more you understand what I just said, the more you understand math.
Professor,
Yes.
did you say you can factor it?
Did I say that you can?
I
Is that
thought
what you're
that
asking?
I thought you can factor the
Oh, how do you factor it?
the top part.
Yeah, how do you factor it?
That take 7a from the beginning.
Or you mean from this
Plus
step?
2 terms. Yeah.
It won't work. Nah. Because if you take a 7a out, that's a minus, and over here you take a -3 out, that's a plus.
Oh.
That's why I said, oh, it almost works.
Oh yeah. Okay.
Okay, but you saw the same thing I did. Yeah, all right, I like it. I like it. Let's see. Is that cool for number 68?
Yeah, I'm good. Thank you.
Okay, and then you have a question number 22 from chapter 2. All right, let's see. Let's see, where are you? Navigation is not easy. Let's see. Oh, crap. I'm nowhere near it. Rawr. Now I'm in chapter 3.
Quick question though.
Yeah.
I notice you have correct on mine, which makes perfect sense. Do you want it to be the corrections of those specific problems, or do you want like the whole page rewritten?
You only have, no, you only have to ever correct what you made mistakes on.
Okay.
Yeah, no reason to redo the things you did right. Come on, where are you? Oh, this is gross. All right, here we go. Number 22. Chumbawamba. Here it is. Oh, okay. All right. It's I'll do one like it, but I basically am giving the answer away. But can somebody, what is the slope between those 2 points? all kinds of chats and I'm not ready for it. Hold on. Anybody?
You can subtract the one relation to the other one.
I mean, how do you find slope, guys? How do you find slope?
Well, 6 minus 7 on the top, and 2 minus 2.
Exactly. And what is that?
No answer.
More specifically,
Undefined.
yeah. How's everybody doing? Do you guys know why we call it undefined? Real quick. Do you guys know why we call that undefined?
I wrote no solution. That's not the same?
No. I'm not done yet.
Okay, go ahead.
I'm not done with the problem yet. All I've done is found the slope, and then I'm going to ask for the equation, which is what that problem asks for, right? So, do you guys know why it's called undefined?
Because 0 can't divide anything.
Yes, but here's why it's called undefined. What is 6 divided by 2?
3.
3, right? All right. So make sure you write that note down. Sorry, so 6 divided by 2. Why? 3 is defined to be the number that when I multiply it by 2, I get 6. What is 6 divided by 0? Is there a number defined in such a way that when I multiply it by 0, I get 6? No, that's why we call it undefined. Isn't that neat? That's why it's called undefined, guys. Sometimes teachers call it infinite because what kind of line would this be? This would be a straight up and down line. Now, there is an equation for the line that goes through those points. Of course there is. What relationship do you see? What is true about this line? If it's a straight line through those points, what's
Are
always
on the
true?
same x.
What is x? X has to be
2.
2. Done. There's the equation. That is a straight up and down line that has an infinite or undefined slope. So don't say you got a bad slope and therefore no equation. Of course there's an equation. There's an equation for the line between any points. Any 2 points. You'll be careful.
Okay.
You will. Good. Let's see. Yeah. Did I miss anything else? I had a ton of chats come in. Hold on. What happened here? We only do even numbers in the homework. You do whatever I assigned for every homework problem. Is that cool? I think on the first couple, was it the even ones? I think so, right? You do whatever I assign. Where we assigned any other homework yet? You tell me. Does anyone notice any more assignments? I love you guys. Let me see. So if you look in Canvas, if you look in modules, oh, let me become a student. I don't think I've done these. I think I did, didn't I? Maybe I haven't put them up here yet. Nope, just 1-1 and 2-1. I am going to put chapter 3 up there because I know a few people are working on chapter 3. But the minute I assign something, it'll show up in your to-do list. It should. And you'll also see it show up in the, there will be a module that says turn in chapter 3 homework here, turn in chapter 4 homework here. All right, I like it. Let me see. Can you go over 58 from chapter 1? That sounds familiar. 58. Here we go. Oops. Yeah, okay, sure. All right. So the thing with this, if I have this, let's say 4 plus y, how would I factor this?
You take x minus 1 squared.
Good. Why take this one out?
Because that's the lowest.
Lowest power, right? So I take an x minus 1 squared and I'm left with 4. plus y times x minus 1 squared, right? And then you could do other shit, whatever. Now, the problem you're looking at is a little worse. Let me make a problem like that one. What do you got, Jeff? You can do it, buddy. There you go. Look at that. All right. Here we go, Jeff. There it is. Yes. All right. So I take out the one that's got the lower power because that's the one that everybody's got. I can't, like up here, I couldn't take out a fourth power because he's only got 2, poor little dude. So which one of these powers is smaller?
Minus 1/5.
Yeah, so I'm going to take out, oh, I didn't mean to do that. Oh, it doesn't matter, Jeff. Let me make this 5. I don't want the numbers getting in the way. Make that a 5. So if I take an a plus 5 to the negative 1/5 out, now this is where you really have to pay attention to how things work. When I took this out, why is there a 2 there? Because 4 minus 2 is 2, right? When I take stuff out, I'm dividing it out. So I subtract powers. So 4/5 minus negative 1/5. What is that? What's 4/5 minus negative 1/5?
1.
5/5, which is 1, 11. Plus 5, and I took this shit out. And now distribute, get your like terms together. That's exactly how 58 and I believe 60 work, if I remember correctly. Is that all right? Is that all right? I love this kind of problem because you can see how taking him out fills him in. That's kind of nifty. And that actually happens a lot in math, to be honest. Okay. You guys doing all right? Real quick. I just got to tell you this one thing. Have you guys ever heard of Red Letter Media? They do like movie reviews. So I was watching the one about paranormal activity, and now everybody that I can see, I keep waiting for something to happen in your background. I don't know. Now it's going to make you all creeped out. I'm sorry. Who's that? No. All right. So did I miss anything? Anything else? Oh, shit. We got more stuff going on. 34 from chapter 1. Let's see. Am I in chapter 1? Yes, thank God. 34. Oh, I did just go over 34. Did you miss it? Or no, was that earlier? Was that during office hours or was that? All right, so the thing with cube roots. So let me start off with this. What's the cube root of negative 27?
-3.
Negative 3. I love it. Why don't I need like an I or something? Why is that not real or something? Because it's a
Because of -27.
it's an odd root.
Oh yeah.
If I have 3 negatives, it still comes out negative, right? 2 of the negatives cancel each other. If I have an even number of negatives, the answer comes out always positive. That's why even roots are so freaking uptight. They cannot handle negatives. Odd roots are completely cool with it. So how would I do this? Become a cube root. What's happening out there? Remember we did this one yesterday? Bam. Remember that? Because I broke it up into something I can do times something I can't do. Okay, what did we get here?
-3.
I'm not sure what to do with that. No.
10 and -27.
Yes. Right? I break it up into a part I can do times a part I can't. The same way I did a square root, right? Now I just got to think in terms of cube numbers. So 25 is not going to help out, but 27 will. Do you guys understand? 8 is good, 27 is good, 64 is good for cube roots because they're cubes, right? 125 is 5 cubed. So that's a good number to use to break something down with. So then I get -3 times the cube root of 10. Bam. That's how to simplify that thing. Same idea, break it up into a part that I can do and a part that I can't do. Then I do the part I can and I leave the part I can't. That's awesome. It's like a life philosophy. You guys okay? I keep asking if you guys are okay because I can only see like a fourth of you or a fifth of you or something. And there's another person. Hey, welcome, Tay. Okay. Did I miss anybody? Chapter 2, number 30. Oh, crap. Here we go. Let me see if I can find chapter 2 quick. You can do it, Jeff. Come on. Chapter 2. Bam. Oh, I actually have the book. That's hilarious, Jeff. I actually have the hardcover book. I'm just remembering. It's so funny. All right, number 30. Oh, okay. All right. Well, all right. This is kind of nice. This is getting into today's lecture where we're going to start. Any other questions before and I will answer this question. It just sort of blends in really well with the first thing we're going to talk about. Anything else before I do that? Okay, all right. So all right. So I'm not going to forget your question, Jordan. But before I answer it, I do want to do this. I promised you guys I would show you a movie, which of course, as I'm sitting down, I'm remembering I completely forgot to actually find, but it should just take me a second. All right. So I want to show you this really kick-ass video that these guys put together.
Just one question.
Yes.
What if it's like the root of 250 cubed over -8?
Sorry, I just found the video. Go ahead. Sorry.
What if it's like the root of 250 cubed over the root of -8 cubed, like in 34?
So cube root of.
Cube
right?
root.
So the cube root of -250 over the cube root of -8. Well, the cube root of -8, you know.
Yes.
Okay, good. And the cube root of 250, can you break that up into a number you can do the cube root of? So what is 4 to the third power? What's 4 cubed?
64.
What's 5 cubed?
125.
Does 125 go into 250?
Yes.
So you can break 250 up into the cube root of 125, which you can do, and times the cube root of 2, which you can't do. So it's exactly like the ones we were just doing. Is that cool?
Yes, thank you.
I like it. So depending on the root, you have to adjust the way you think. You have to adjust which numbers you try. So if I have square roots, I'm trying 4, 9, 16. If I have cube roots, I'm trying 8, 27, 64, all that kind of stuff. I like it. I like it a lot. All right, so let me show you this kick-ass video. I'm gonna have to stop recording because there's actually a whole series and they go deeper into it and they bring some other ideas in, but that's pretty good.
Come up with all these elaborate backstories.
Oh shit!
I got help from a pro. My financial.
Let's all listen to the ad.
How Nationwide
Hold on.
Solutions can help Mr. Paisley retire early.
I'll be quiet. All right. That was weird. I'm like, who's talking? You sound like you should be in radio. What's going on? All right, so Nationwide, that's exactly right. All you got to do, kids, is become a great football player, and then you too can be in Nationwide ads. Here we go. Okay. So I already gave you that picture. Remember we talked a little bit yesterday about they mean rotations. So that video didn't really get into the idea of rotations, but it does get into the idea of the axis being here making sense because half of a rotation, if a rotation is multiplying something by -1, then multiplying by half a -1 would be this much of a rotation. So that must be the complex axis. All right, how we all doing out there?
That's kind of similar to like radians and stuff, right?
Yeah, there's a I don't know if you guys are, I don't know if you guys noticed this equation. It's on a shirt. I think I wore my shirt. It might have been yesterday. This equation, believe it or not. All right, there's so much weird shit, but you know the letter pi, you know the letter E, right? And what do I mean by that? I mean what it represents, right? E is for population growth and stuff like that. Pi, you all know good old pi. I is what we're talking about now, and 1 and 0. And so math people geek out because we have 5 very important numbers all in one equation. This actually has the idea of radians in it. And if you don't know what radians are, that's part of what we're going to talk about this semester. That's in trigonometry. That's something to use instead of degrees. Degrees are completely made up bullshit. Radians are actual measurements. So we'll talk about that. So we know I is this. Oh, let me show you. Let me actually focus on this part. I'm building my way up to your question, Jordan. Let me get this bigger. Let me focus on this. What would this be? If that's I, this will be
Negative I?
negative I. Makes sense, right? So 2I, negative 2I, 3I, negative 3I, just like a normal axis, except it's what's unfortunately called the imaginary axis. Now, stay with me. This is way cool.
Yeah.
This is so cool. 1 turn means I to the first power. Right, 1/4 turn. Are you with me? So what's I squared?
-1.
-1. Crazy. So what's I cubed?
Negative I.
Negative I. That's crazy. So what's I to the 4th?
1.
1. So what's I to the 5th? It repeats. Oh, Jesus. All right. Now, let's break that down more algebraically just for a minute. Why does it make sense? If I is the square root of -1, then obviously I squared is that squared, which is -1. So everybody with me? Yes? And what would I cubed be? I cubed is I squared times I. I squared is -1. So I cubed is -I, which is exactly what we just got from this picture, right? And of course, what would I to the 4th be? The easiest way to do that is I squared times I squared. -1 times -1 is 1, which is what we got. And then it starts over. So this is also I to the 5th, I to the 6th, I to the 7th, I to the 8th. So can you tell me what this is? I to the 212. Tell me. No work. Tell me.
Oh, I have a question.
Oh shit. Yes.
So I to the 2, isn't it should be 1 positive?
Definitely not. Definitely not. All right, let's focus on this. What is the square root of 11.3 squared?
Sorry,
What's this? The square root of 11.3 squared.
11.3.
11.3, of course. Because what does a square and a square root do to each other?
Cancel each other.
oh, cancel.
Cancel each other out. What's the square root of a squared?
A.
A. So what's the square root of -1 squared?
-1.
Totally.
Yeah, that makes sense.
Totally. Your brain is not liking this because you are so ingrained with the idea that everything squared is positive. But that, if your teacher has said that, I don't know if I ever say that, but I always try to make sure that I say no real number squared is negative. This is not real. This is officially called imaginary. So that's why this breaks that rule that's in our brains. I like it. Free your mind. There is no spoon. No, okay. All right, so can anyone tell me what I to the 212th is?
1.
Yes, why? Because what happens every fourth? I to the 8th, I to the 12th, I to the 16th. It comes back to 1. This is what's called a cyclic process. Cyclic, right? There's a cycle to it. It's crazy. So, real quick. I'm going to erase all this stuff. You ready? So there's kind of like the computational way, and this is a beautiful visual way to remember the powers of I. Which sounds like a really weird self-help book. The powers of I. Okay. All right. I'm going to take it all. Here it goes. What about this? Who's got what this is? I to the 306. Here's the way to do it. 4 goes into 306 so many times with how many left over? Do you guys know? 4 goes into 304 even.
2.
So there's 2 left over. So this equals I squared. So, and then of course, I squared is -1. Done. Why? Because every fourth one it starts over. So how do I know where I am in the cycle is what the remainder is when I divide it by 4. Isn't that beautiful? Or, acceptable? I don't know. All right. You guys are like, whatever. So that's the quick way to figure out I to any power. It's sort of like -1 to any power. -1 to an even power is positive. -1 to an odd power is negative, right? Because it only has 1 -1, 1 -1. It bounces, bounce, and now I'm adding another. Now I've got 1, 2, 3, 4. 1, 2, 3, 4. And it's the same idea. It's cyclic. It's just got more stops. Okay. Now I'm finally ready for the question that I was asked. So this is a complex number. It's real number plus a complex piece. So every number you've ever seen is complex. Right? What about the number 11, Jeff? Well, that's where A is 11 and B is 0. There you go. Every number you've ever seen is complex.
Sorry, did you say that the BI is the complex number, or together the unit is the complex number?
Yeah, so B is a real number. BI is an imaginary. Right? But when I get a real number plus an imaginary number, that makes a complex number. So this is specifically imaginary, but it's a complex number where A is 0. This is specifically real, but it's a complex number where B is 0. So you got, how do I want to say this? Yeah, you got reals, you got imaginaries, and then you got complex. This is where B is 0, and this is where A is 0. And then this, anything out here would be where neither A or B is 0. It's a combination. Do you guys get that? So complex is the more general term. It's a real plus an imaginary. Okay.
Yeah, okay.
Oh. Yeah, okay.
I have a question.
Yes.
Why it has to be 0 either side?
0, what do you mean? Sorry. To be completely real, this has to be 0, or else you're not completely real.
Oh, okay.
Does that make sense? Yeah. And to be completely imaginary, this one's got to be 0, or else you're not completely imaginary.
Okay.
I like it. But the more general thing is everything's complex, right? Okay. So that might make you feel like working with these things is going to be difficult, but it actually is the easiest part. Working with these things is the easiest thing yet. What does your gut tell you about the right way to turn this? Okay. About doing this, simplify 6i plus 2 minus 5i minus 7.
Is it typically okay or frowned upon to treat the I like a variable?
It is completely okay,
Okay.
at least to begin with, right? And I'll show you what I mean in a minute. Because, all right, I really want you guys to understand this. Even though I is not a variable, let me ask you this. What is 2 rad 7 plus 3 rad 7? You can do it.
5 rad 7.
5 rad 7. Is it very cool? Didn't you treat that like an x? 2x plus 3x is 5. 2 somethings plus 3 somethings is 5 somethings. Is that a variable? No. Can you treat it like a variable? Yes. Because what I'm really doing with variables is just consolidating what's the same, right? So what do? How many i's do I have? I mean, you really should bring that through, right? Just to be careful. Because some of you guys have a problem with that. All right? Make sure you change the signs. Now put your like terms together.
I plus 9.
I plus 9. Yay. So those are easy. That's some easy shit. Adding, subtracting complex numbers is easy. Multiply them is also easy, just a little bit of a twist. So how would I multiply these two? So you start the same way as always, like somebody suggested, treat it like a variable. So what's 6i times 5i?
30 multiply minus 1.
Sure, you're getting a little heavy. So 30i squared minus 42i. You guys with me? You have to be with me. That's all I'm doing. I'm not doing anything amazing. And then you got, let me not even do this yet. Put my like terms together. Now, if they really were variables, that's where you would stop. But that's not a variable. That's an actual thing. And I know what I squared is, and you already said it. What's I squared?
Minus 1.
Negative 1. So this would be negative 30. And then I got one more thing I can put together. Is that all right? So it's like one more step than normal because I is not a variable. It's it's a radical. So if I'm squaring it, I should be able to do more with it. Yes. What's
The
happening?
real number comes first.
Say again, sorry.
The real number comes first.
Oh, it doesn't matter. I mean, if you want to get technical, sure. A is negative 44. B is negative 32i. So it's, for example, if I wrote an equation of a line like this, is that wrong? No. That's the M, that's the B. So I've written it kind of out of order, but who cares? But you're right. As long as you can identify A and B, you're good. All right, I like it. Easy to the 6th power. Okay. Not sure what that means. All right. Let me think. Do they do it? Oh, yeah. So how do I do you guys remember how to do this? How do I do something, Jeff? There you go, buddy. How do I do this? How do I simplify that?
Common denominator?
There's only one fraction, so no.
Conjugate.
Conjugate. What would the conjugate of this be?
Rad 2 minus rad 5.
Do you guys remember that? The good old conjugate? Yes. And that works for what kind of radicals? Square roots, right? Cube roots that wouldn't really work nice for any other root, but square roots, it totally works. I almost don't care what that problem is. You can do that, I don't care. But the reason I put that up there is, how would I do this problem? Hopefully you're cool with that. I don't give a shit what that answer is. I just want you to realize, isn't I a square root? So how do I handle this? The same damn way. It's just another square root. So what would I multiply by?
4 minus 3i.
Totally. Isn't that cool? Guess what we call this? We call that a complex conjugate. Because we're creative math people.
Would you, so you said it works for square roots, but does it work for not cube roots, but any even ones or just square?
No, because you got to think about you can't have like, how's a quick way to explain this? It's very, very simple to get a difference of squares pair with the square root, but the minute you get higher roots, they need more things. Does that make?
Will we be dealing with higher roots?
No, there you go. So that's an excellent answer, is you don't have to worry about it, but I kind of hate that answer, but yeah, you don't have to worry about it. Okay. It would be very, very specific kind of problem that you could actually use if there were higher roots. It doesn't work for all. Yeah. And then this one, let's go ahead and do this one real quick. You guys do this one. I'll stand here. Stand here and make money just watching you guys work. Ha ha ha.
Would it be 21 minus 23i?
Let me see. I haven't gotten there yet. 20 minus, it should be 14 minus 23i, right? Am I thinking about that right?
Yes.
Yes. So yeah, you get 20 minus 15 plus 8. I'm sorry, minus 15 minus 8, so that's minus 23i. Then you get plus 6i squared, which is going to become minus 6, which makes it 14, right? And on the bottom, you get 16 minus 9a squared, which is 16 plus 9, which is 25. I might have done that too quickly. I'm sorry. Is everybody with me? I don't have to worry about the middle because I've designed it for the middle terms to cancel. So you get 16 minus 9i squared. So then that becomes minus 6, so that's 14. And that becomes minus negative 9 plus 9, that makes 25. Shabbat. Relatively simple, right? I mean, compared to some other stuff, that's not that bad. It really isn't. You might have thought it would be. Now, if you actually took a course in complex analysis, let me just tell you, that gets interesting. Oh, shit. But thankfully, we don't do too much more with complex numbers here. That gets very difficult very quickly. Okay. Oh, I want to do this. The very first part of chapter 2 actually deals with graphing. So I want to show you a couple things. I want to show you, let me do it this order. Let me see. So here is a graphing calculator emulator. Woo. Right, let me clear all that crap away. One of the questions I ask on the survey is if you've used a graphing calculator much at all. Is anybody here going to use a graphing calculator for the first time in this course? Anybody? Everybody's used a graphing calculator in some capacity. Are you guys telling me the truth? That would be awesome if you're telling me the truth. Okay. All right. Maybe you can tell me later personally if you don't want to say anything now, if you've never used one before. But up here, y equals is where I plug stuff in. So I got a function sitting in there from I don't know when, right? So if I hit graph, Ooh, I see the graph. Okay, right. That's amazing. So when we do hit things in the book that require you to do things in the graphing calculator, we will go over those together. I want to show you something else. On Canvas, I have put something new. Let me become a student. If you look right here at the end, TI Calculator Basics. Now me, see, this is my student account. I am really behind. So all of this is locked off to me. So let me leave my student view. All right, computer. There's the Calculator Basics. And it does a good job of, I didn't create this. I think I created part of this and then they updated it for a workshop they did. Yeah, so you can look through there if you want to. There's a lot of cool Zoom shit and all that kind of stuff. All right. So some of this stuff, it sounds like maybe most of you guys know a decent amount of this, but you know, it's a really decent little quick summary of some basic stuff. Oh shit, let me see. No way. Okay. I'm not sure what that's. See, I have Pac-Man and Tetris on my graphing calculator. Does that count as using it? It technically does. Good job. I have a different game. My game is like not something you would know. Okay. Let me think. Oh yeah. Now here's the coolest thing. Now here's the part you guys are gonna get. I don't know if you're gonna get upset about or not. I don't care. I also have put this up here, which you're not really allowed to use your computer in general when you do tests and stuff. Has anybody ever used Desmos before? Desmos kicks so much ass. Desmos is an ass kicker, right? So let's see, x squared minus 7x plus 6 or something. Look at that shit. And when you go over it, it tells you the intercepts, it tells you the vertex. I mean, look at that. Isn't that beautiful? So then if I had another equation, I can put in there y equals 2x minus 3. And then it will even tell me the intercepts between the two functions I put in there. Do you guys see that? Those are the intercepts for the two functions. I mean, holy shit. So Desmos is really kick-ass. Let me see who's chatting at me. I can't handle all this technology. You love Desmos. Oh. There's something about intelligent people cuss, and that's when I started to cuss. No, I'm joking. I don't know. I don't really cuss in my everyday life, but when I'm teaching, I try to channel what I think some of my students are thinking to themselves sometimes. Like, what the shit is that? And just a real quick word about my cussing. This morning, somebody private messaged me and they said, I don't mean to offend you, but can you please watch out for your language? It kind of upsets me. I'm like, I can't promise you anything. I'm sorry. So if I upset you, if I offend anybody, then just wait a minute. I'll probably do it again. Okay. Now I'm just talking about my cussing. If I offend you in some other way, obviously, let me know. But kick them out. No, I'm not going to kick them out. Give me a break. They can sit there and be upset. All right. There was something else I wanted to show you. Oh,
so
yeah.
Desmos is cool and all, but do we actually get to use it, or is it like for a study technique?
No, you can use it on your homework. You can use it in general. It's really cool. It's just that when you're taking a test or a quiz or something, I'm not going to really let you use too many out there kind of products. Do you understand?
If we use it in homework, do you want us to like take a photo of it or recreate it on?
See, this is the beauty about scanning stuff. So you can scan what you've done on your calculator or on Desmos, whichever way you want to do it. Does that make sense?
Yeah.
Okay. All right. And the last thing I want to show you, it's not really about this class. So you can say, why are you showing me this? But I just want to show it to you. Nick was a student of mine in my Calc 3 class. So this is a 3-dimensional image, right? And it's got some trig function stuff in there. So we're going to learn trig this semester. And trig, of course, is the ones that look like, some of the trig functions are the oscillating stuff, like they make this the up and down, right? The oscilloscope stuff. You guys know what I'm talking about? So he actually designed this thing that graphs three-dimensional objects and lets you kind of manipulate them and see all this cool shit. That's nothing we're going to do in this class, but I just wanted to show off his work. It's some kick-ass cool stuff. So if anybody has to take Calc 3, if that's in your future, that's called plot.ninja. Plot.ninja. If you just want to play with it, it's pretty cool. Please don't stop. Okay. What time is it? Okay, so let's do a little bit more. I want to make sure we finish out chapter 2. Where did I put the book? Dadgummit. I've lost the entire book. Okay. There's chapter 2. Hold on, guys. Hold on. So there were complex numbers. It starts with graphing, very simple graphs, graphing lines. That should not be a problem for any of us, right? Finding the slope, finding the y-intercept. Let me look this up. And then it goes into word problems, right? So section 2-3 is about word problems, right? Which is normally everybody's favorite thing. So don't worry, there are pre-calculus word problems, so you're not going to get cheated out. We will do word problems in pre-calculus. Yay! Then the complex numbers, and then we get into quadratic equations, right? So I want to talk about quadratic equations for a little bit, and then we might call it a day. We'll see, because we're almost there. So let me show you this. I think I showed you this before, but on Canvas, I have posted quadratic, let me see, where are you? Leave. Oh, yeah, right here, quadratic equations handout. So it kind of reviews stuff like completing the square, quadratic formula. So here's completing the square. I don't even know if do you guys remember completing the square? Does that sound familiar to anybody? And then here's basically everything: factoring, the square root principle, which you guys have already been using in your homework, completing the square, which I don't know, we might do a problem real quick, and then quadratic formula, of course, right? So that should be review, but let's do completing the square, because that's the one everybody always forgets about. And it does have a purpose. I'm sorry, go ahead.
The quadratic the thing that you just showed us, mine didn't have that second page. It was like, here's the first touches on like divide the middle term in half and then square it, and then it just went straight into try it on your own.
Oh.
I know, because I just literally copied that page to a piece of paper.
So yeah, here's this one, and then if you keep scrolling down, it's there. Yeah.
Okay.
Yeah,
Sure.
and you can download it up
again,
here. If you click this, you can download it. So maybe
No,
it should,
yeah, I downloaded it. But
Oh,
yeah,
shit.
I will absolutely double check. And if it's still messed up, I'll message you, I guess.
Kyle, what's that mean? 50% homework? I don't know. All right. Bam. What was I about to show you?
Sorry.
That's all right. It doesn't take much to derail my train of thought.
You were talking about quadratic equations, and you were looking like you were about to talk about something that was similar to
Yeah,
it.
yeah. So let's do, I can't remember now. Let's do completing the square. I think that's the main thing I wanted to talk about. Yes, that's it. Okay. So, somebody real quick, what is this? If you do this, what do you get? Don't tell me x squared plus 16. Get out of here with that shit. That weak ass shit. Can you see it? All right, yes. Okay, good. What do you get when you FOIL that out?
X
X
squared
squared plus
plus
8.
8x.
8 is twice 4, right?
Yeah,
And 16 is 4 squared, right?
yeah.
Okay. What's this?
X squared minus 14x plus 49.
Negative 14 is twice this, and 49 is this squared, right?
Yes.
So what completing the square does is it says, okay, what if I had this? I and I wanted to add something here to complete it so it becomes something squared, complete the square. So I want to figure out what number can I add here so that it factors like these. So watch, half of 8 is 4. 4 squared is 16. Half of negative 14 is negative 7. Negative 7 squared is 49.
25.
25 goes where?
X squared plus 10 times 25.
So it's 25. And then half of 10 is?
5.
5. Okay, I like it. So if I had a problem like this, what do you got, Jeff? I don't know. Yeah, sure. Oh, let's not go too weird. Hold up. There. Sure. Okay. What would I have to add to this? Same idea, so that I can, on the next step, I can write it as something squared. What are the 2 steps? Cut this guy in.
Divided by 2.
Divided by 2. And then
Square it.
Square it. This tells me what the answer is going to look like. This tells me what I have to add. If I add it there, I better freaking add it there, right? All right, that's the basics of one of the most basic uses of completing the square. It's definitely not the only use of it, because now what can I do? Now I can do this. And then subtract 3, and I'm done. And sometimes that process I just did is quicker than quadratic formula would have been. So quadratic formula is not really a shortcut all the time. It is sometimes longer than if I just did this. You guys feeling okay? Does that sound familiar at all? You guys remember doing this?
Can we touch on a quadratic formula problem similar to like 26?
All right, let's do
Yeah, touch it.
okay. Let's do this one. All right. So this one started off like this, right? So it started off equal to 4, so I'm going to put minus 4. Right. So of course, quadratic formula. Do you guys remember?
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Everybody, come on. That was awesome. Come on. There we go.
You could just hear the confidence like derailing.
There we go. No, it's beautiful. There's nothing wrong with that. Yeah, that's basically it. And then you just, have you guys ever seen why the quadratic formula works? Anybody? What is that, 13? No. 4 goes into it. It is 13, isn't it? Yeah. Yeah, okay. Is that the same answer I got here? Yes, thank God. Right? So pretty cool. Rad 52 is rad 4 times rad 13. So 2 rad 13. And then you can divide everything by 2. So I do get the exact same answer, thank God, because it's the exact same problem, right? I like it. Let's see. Yeah, we got time. Okay. Since you guys want me to, I can hear it in your silence. I'm going to prove the quadratic formula to you. Does anyone object to seeing that? Has anyone ever seen that? Do you guys know why the quadratic?
To be fair, I feel like we're silent because we're all muted.
Oh, that's fine. But you have the ability to unmute yourself. So that's okay.
Totally on board.
Yeah, I didn't hear anybody unmute and go, please don't. Okay, so real quick, and if you don't really follow this, it's not the end of the world. But if I start with this, and what I'm going to do, one thing about completing the square is it only works when the first number is a 1. Everybody with me? So I'm going to have to divide by A. And I'm going to subtract the C stuff over. Is everybody cool with what just happened? Subtracted C and then divided by A. Now here's where you have to realize the process does not require much thought. It is such a brute force thing. What are the two steps? How do I figure out what to add here? What are the two steps? What do I do with the thing in the middle?
Divide by 2.
Divide it by 2.
Square it.
And then square it. This tells me how this will factor. If I add this, did I get it all there? Yeah. If I add that to both sides, get out of there. That's what has to be added, and that is how this will factor. Did I have to think much for that? No. And this, can you guys see? And again, I'm going to do this a little quickly. I'm going to multiply top and bottom by 4a, so they have like denominators, right? You guys see that? I just multiplied by 4a, so they have the same denominator. Denominator. I never know when to end that word. All right. Then I can take the square root. Is it looking familiar already? Equals plus or minus square root b squared minus 4ac. Jeff, you made that too big. Over square root of 4a squared is 2a. And then I just subtract b over 2a. Same denominator, right? So I can put negative b plus or minus. I mean, you got it now. Square root of b squared minus 4. I don't even want to write it down, blah, blah, blah. All right, you're there. Okay, so that's the proof. Woohoo! There's actually a really cool method somebody figured out that's kind of like related to a way I used to try to do this shortcut thing, but they've developed it all the way out, a shortcut, but who cares? What else did I want to show you? I think that's, let's make sure that kills chapter 2. Want to kill chapter 2. Pretty much. I mean, the last thing in chapter 2 are inequalities and absolute value inequalities. Now those get interesting. So that's let's talk about those real quick, because this is where I can talk about restraining orders and how they relate to math problems. Restraining orders, haunted houses, and math problems. So how do I do, remember this? I think we did a problem like this, didn't we? Yeah, we did a problem like this, right? How did we do this? We said, do you guys remember?
X minus 2 equal to 5. Minus
-5.
All right, and then we get our two answers. Yay, yay, blah, 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 who cares? Okay. And real quick, I want you guys to realize something. Absolute value means distance. So the answer to this question would be all the numbers that are 5 away from 2. So what's 5 away from 2? What's 5 up from 2? 7. What's 5 down from 2? -3. I mean, so there's, you know, if the equation in here is not too freaky, and the minute I put any number here that's not 1, it gets freaky, then I can actually just visualize the answer very quickly. Because it's distance. So what happens if that's not an equals? What happens if that is an inequality? I don't know. So let's say it's less than or equal to 5. So now what's going to happen? What should be the answer? I want the distance to be at most 5. So then shouldn't it be all of these numbers? Right? Shouldn't it be all those? I want to stay close. I don't know if you guys are understanding.
Yeah, that makes sense.
Maybe a little bit. So if this is exactly 5 away, and this says I want to be at most 5 away, then my answer would actually be all of those. It would make a sandwich, right? A sandwich is a yummy sandwich, right? Is a sandwich. Okay. Bread, jelly. All right. But how do I do that algebraically? How do I show the work? Well, let's see if you guys get this. Either this, let me ask you this. All right, let me think. How do I want to show this? how do I show you this? Yeah. What can somebody tell me a number? Can somebody put a number in here that makes this work? Like, does 7 work in this?
No.
No. Give me a number that works.
3.
3. Does -7 work?
Yeah.
Think about it.
No.
What's the absolute value of -7 is 7,
Oh.
which is not, right? So watch this. Let me see if you guys are cool in this. It's got to be contained. So x minus 2 has to either be less than or equal to 5, like 3, but I can't keep going forever down. Do you guys understand? I can't just keep going forever down. There's a floor also. What's the smallest number I can put in here and this is still true?
-5.
-5. So there's a floor and a ceiling that this is between. And this is what I call the haunted house problem. If I go into a haunted house, I want you to stay close. I want your distance to be less than something away from me, right? Because we've seen horror movies. We're smart. We're not going to split up. That's stupid. You guys, all right? You guys with me?
Yeah.
All right. And now you just add 2 to all sides, and we get the same answer. You can do it, Jeff. Can you do it? I don't know anymore. There. -3 to 7, right? Which is what we got. So of course, what's going to happen if it's greater than? That's a situation where I don't want you near me. That's the restraining order, right? So if this problem was greater than 5 or something, now I want this to be either greater than 5 or this to be less than -5. I want you either more than 5 up or less than -5 down. Just stay away from me, right? So I can still see the 2 cases. There's always 2 cases with absolute values. So let's see what we get. X greater than 7 or x less than -3. And that makes sense. Here's 2. Be at least 5 away from me. So that makes sense. Look, oh, not like that. You can do it, Jeff. There you go, buddy. So stay at least 5 away from me. That's exactly what we get. All right, that was a very quick.
How would you write that in interval notation?
What's this piece?
Greater than?
Open.
-infinity.
-infinity up to. And what symbol do I put in the middle of the 2? There's another one up here, right? Or how do I do this one?
7 to infinity.
Done. I like it. These are opposite of each other, right? So the answer to this is everything this one leaves out. And you can see that the answer to this is -3 to 7, which is exactly what this guy leaves out. I think of this as saying skip. -infinity to -3, skip to 7. All right, that was a little bit quick, but it should be a review. And then I think that's enough. I think that's a good place to stop.
I do have a question.
Yes.
Yesterday we were graphing this type of problem on like a graph. And we had the V, obviously. Will there be problems where the slope is different that's gonna like mess with the V? How did we originally graph that problem?
So I want you to realize to make that happen would be very difficult in a single function. So you could have something called a piecewise function where things like that happen. Has anybody ever heard piecewise function? Not pennywise, don't worry. The functions all float. No. Sorry. Let me do that. All right. But a piecewise function, it's a function that changes definition at certain points. But to have an absolute value function where the slope is different on either side of its vertex is not a simple thing to achieve with this. So we're not going to see that really.
Okay. And then another question is we graphed something that looked almost exactly like that in our homework, and it said to shade the areas that it
It just means like shading like this.
on that type of graph? Because I thought it was talking about the V
Yeah,
graph.
so I think it's taught, is that the one about the greater than 5 or something, right?
Yeah, okay, so it looks a lot like that. It's the absolute value of x plus 3 is greater than or equal to 5.
Yeah. So you get something like this basically. So it would be greater than if so it would be this here is where it first becomes greater than, right?
Yeah.
Because here's 5, so where does it become greater than? There. So I'd shade this, and there I'd shade this.
So why would you not shade the little triangle in the top left?
All right, so I'm not thinking two-dimensionally. I'm thinking what inputs make this happen. And
So it
you're
just cares
thinking-
about the x only.
Yeah, because there's another problem that you guys, so you graph a line and then you shade one side of it. Do you remember?
Yeah.
That's a whole different thing. That's
Okay.
not what this is getting at. Yeah.
So I realized it asked us to shade and I did not, and you did not mark it.
Yeah, because I don't care. The shading doesn't really change anything.
Okay, cool.
Yeah,
Rep.
it's kind of silly they asked you to do it, but you know, we move along. All right, guys. That's it. You can leave if you want to, if you have a question. Now I got that song in my head. Yeah, you can dance. if
Bye.
want
Thank
to.
you, Professor.
You're welcome. You can leave
Bye.
your friends behind. You're welcome.
Have a good night.
Your friends don't dance, live, they don't dance.
Thank you, bye.
You're welcome.
So I noticed same problem actually. I apparently annotated the answer wrong because I did bracket 2 comma -8 bracket. Or sorry, not bracket, include, whatever you want to call the include thing. And apparently I denoted that wrong. Was I supposed to do it like, I don't know, with the 3? So it was like -8 is less than or equal to x, and x is greater than or equal to 2.
All right, wait a minute. Are we talking about we're talking about a homework thing that I looked at? Is that right?
Yes, I'm sorry. We're talking about
All
number
right, so
68.
let me
still.
look
It's
at it.
the
Look at
same
it.
thinger.
68 in what section?
Chapter 2.
Chapter 2. Okay, here we go. Here it is. Okay. Here, let me go ahead and stop.